Hello students, this is lecture 3 of Mole Concept series. In this lecture, we are going to study about average atomic mass, average molecular mass, percentage compositions, as well as empirical and molecular formula calculations. So we are going to start with average atomic mass. And to calculate average atomic mass, we must know what is average atomic mass and how we are going to get that. So before studying that, we have to know the concept of isotopes. What are isotopes? As you have studied in ninth class, that isotopes are atoms having same atomic number but different atomic mass. Such as there are three isotopes of carbon. I am writing here. So in case of isotopes, the number of neutrons is different. In first one, if you calculate number of neutrons, it should be mass number minus atomic number, that is equal to 8. So in first isotope, there are 8 neutrons. In second isotope, there are 12 minus 6, there is 6 neutrons. In third isotope, there are 13 minus 6, 7 neutrons. So number of neutrons is different in each case. Because of that, mass number is coming different. So all these atoms will have different mass number but same atomic number. So we call all of them as carbon, but their mass is not same. So it's not necessary that each atom of an element will have same mass number. Mass number can be different, but atomic number will remain same. For every element, the atomic number will remain same. For each atom of every element, the atomic number will remain same, but mass number can be different. So you have to keep that concept in mind. So if we say that we have out of 100 molecules, we have 10 molecules of carbon 14, 10 molecules of carbon 13, and 80 molecules of carbon 12. In that case, how we can find out the average mass of these 100 atoms? So there is a very simple formula. We can directly use that, or I can show you how empirically or mathematically you can calculate. So basically what you have to do, you have to calculate total mass of these atoms, then we have to calculate total mass of these atoms, then we have to calculate total mass of these atoms, divide by 100, total number of atoms, so that we can get average. This is the formula of average. Simply, we are calculating all the mass of 100 atoms and again dividing it by 100 in order to get the average mass. So what we can say that 10 into 14 plus 13 into 10 plus 80 into 12. You have to calculate that. I am just trying to calculate 140 plus 130 plus 1080. Is that okay? Just add all of these terms. We are going to get a value as 000, 8 plus 3, 11 plus 4, 15, 1 plus 1, 2, 2 plus 0, 3, 1350. Is that okay? We got total sum as 1350. Again divide it by total number of atoms. We got total mass is equal to 1350. Total atoms, that is equal to 100. So the average mass will come as 13.50 grams. It was very simple mathematically, but we calculated total mass of these atoms, divide by total number of atoms to get average mass. If we try to convert this into mathematical formula, it will come as summation Ni MWi divided by summation Ni. N is the number of atoms present basically. We can calculate it through percentage composition also, and we can say it directly also. Okay, it can be also calculated through mole fraction. So that's how we can calculate formula for average atomic mass. Though this formula looks quite difficult, if you know summation, you can easily calculate. But if you don't know summation, Just simply what you have to do. I'm just taking one numerical, just check it out how I am doing this problem, and you can follow the same process. Okay, you have the question in front of you. Chlorine occurs in two isotopic forms. One is chlorine 37, the other one is chlorine 35. The percentage composition of chlorine 37 is 25%. Calculate average atomic mass. So how we can calculate? We just have to think. First, what you have to think is that if percentage of chlorine 37 is 25%, what is the composition of chlorine 35? So first thing is percentage is calculated out of 100. And if one part is 25%, the other part should be 75%. So I can say that percentage of chlorine 35 will be 75%. Is that okay? After that, what we have to do is we have to calculate average atom. As I told you that percentage is calculated out of 100. So you can assume that total number of molecules is 100. Out of that, we have to calculate average atomic. So I can simply say that there are 75 molecules of chlorine 35 because out of 100, 75 molecules of chlorine 35 will be there. So 75 into 35 plus what is the percentage composition of chlorine 37? That is 25%. So number of molecules out of 100 of chlorine 37 should be 25. So 25 into 37 divided by 100. Is it simple or looks typical? It looks simple, I think. I am taking 25 common. What I am going to get? 3 into 35 plus 37 divide by 100. It will come as 4. So 35 into 3 will be 105 plus 37 divided by 4. It will come as 142 divided by 4. 5.5. So we got average atomic mass as 35.5. Was it simple or typical? It was very simple. Basically, what we did, we assumed percentage as 100 molecules, and out of these 100 molecules, 75 molecules of chlorine 35 were there, and 25 molecules of chlorine 37 was there. So through that we calculated the average atomic mass. First we calculated total mass of 100 molecules. Then we divided it by total 100 molecules. That's how we got average atomic mass. So calculations of average atomic mass are simply very simple. You just have to think and apply little bit of math. So you have one more question in front of you. You have to calculate average molecular mass of air if air contains 80% N2, 2% CO2 and 18% O2 by moles. It should be by moles, percentage by moles. Okay, I'm just making it simple. You can calculate through by mass also. So percentage by moles, we have to calculate average molecular mass. What is average molecular mass? As you know, the molecular mass is the mass of molecules. Basically, mass of molecules is molecular mass. In this case, we are calculating average molecular mass because molecules will also contain isotopes. So because of those isotopes, the molecular mass is going to change. In case of air, air is not a compound, not an element, though it is a mixture. For mixture also we can calculate average molecular mass. Okay, we are assuming air as a simple molecule, though it does not exist as a molecule, it is a mixture, but we are simply assuming it as a simple molecule. So we have to calculate average molecular mass of that molecule if air is made up of those molecules. Okay, you just simply have to understand this in your mind that we are simply assuming that air is made up of simple molecules instead of mixture. Though air is made of mixture, but we are keeping that aside and assuming that air is made of simple molecules. And what will be the average molecular mass of those molecules? So simply what we have to do, we have to assume that air is made of simple molecules and calculate mass from that part. So first what we are doing, we are calculating total mass of each, we are calculating total mass in case of air if composition is given. So we are again assuming, as it is given in percentage, we are assuming 100 molecules total. And can we calculate mass from these molecules? I can simply say that 80 into mass of nitrogen should be total mass of nitrogen out of these 100 molecules. So mass of N2 will be 28. Mass of each nitrogen atom is 14. Mass of N2 is 28. Plus, what is the mass of CO2? It should be 2 into 44. Mass of carbon is 12. Mass of each oxygen is 16. So if you add up, it is going to be 44. What is the mass of oxygen? 18 into 32. Mass of each oxygen is 16. So we got total mass. We have to divide it by total number of molecules. That is 100. So can we calculate average atomic mass of air? Just try it so that. So I am doing it as 240 minus 2400 minus plus 88 plus this will come as divide by 100. So just try to do the calculation. What value I am getting? 2240 plus 88 plus 540 plus 36. It should come as 576 divide by 100. Okay, we are going to get a value as we sum up 6 plus 8, it should come as, so it will come as 28.64. We got the average atomic mass of air. It is close to N2 because major percentages of N2 we are getting a value as 28.64. That's how we can calculate average molecular mass. It's also very simple. We are going to apply same formula, but instead of atomic masses, we have to put molecular masses. So that's how we can calculate average molecular mass. Okay, our next concept is empirical formula calculations. How we can calculate molecular formula from empirical formula. What is empirical formula? Empirical formula is the simplest ratio of atoms in whole number. Simply, it is the simplest ratio of atoms. Simply, it is simplest ratio of number of atoms present in a molecular formula in whole number ratio. So, how we can calculate the empirical formula, and from that can we calculate molecular formula? The calculations of empirical formula are a bit mathematically typical. That's why I am using this proper data, because so that I can get exact answers. Okay. You have to do calculations manually. Instead, I am using the direct calculations, but I did what is given already. What is given already. So simply, first we are provided with percentage composition of each element in a compound. We have to calculate empirical formula from that. Simply, first divide it by molecular mass. Divide percentage composition by molecular mass or atomic mass. Simple word is because we are taking atoms. Divide by atomic mass. Okay, in this head, what we have to do, we have to divide 40.687 by 12, 5.085 divided by 1, 54.228 divided by 16. What is the value we are going to get? This will come as 3.39. This will come as 5.085. This will come as 3.389. Okay. After this, what we have to do, we have to take smallest number out of these. We have to take smallest number out of these and divide everything by that number. So out of these, this one is the smallest number. So we are dividing each term by this number. So first one will become 3.39 divided by 3.389. Second one will become 5.085 divided by 3.389. And this will become 3.389 divided by 3.389. First one will come nearly as 1, the second one will come nearly as 1.5, the third one come nearly as 1. Now we have to convert these ratio into simplest whole number ratio. So we can simply multiply each term by a number so that everything becomes whole number. So we are multiplying by 2 so that 1.5 can become 3. So this will be the empirical formula 232. So the overall empirical formula will become C2H3O2. Was it simple? Was it typical? Basically, you have to memorize what I did in each step in order to get the empirical formula. Okay? Just think about it and calculate. I am again repeating the steps. In first table, you have to write down the symbol of each element. In second table, you have to write down the percentage composition. In the third column, you have to write down you have to divide by atomic masses, percentage composition by atomic masses. So we are going to get some numbers. Out of these numbers, we have to find out the lowest number, and we have to divide each term by that lowest number. We will get some numbers after that, and we have to convert those numbers into whole number. So we are multiplying by some number, it can be anything, so that we can get the simplest whole number ratio. And we got it. That's how we calculated empirical formula. How we can calculate molecular formula from empirical formula? Simply assume that empirical formula, whatever empirical formula is there, empirical mass, this is EM is empirical mass, into n times, n can be anything, is equal to molecular weight. Molecular weight will be n times empirical weight. We have to calculate this number n. If molecular weight is given, we can calculate empirical mass, and we can also calculate the number n. Multiply each term by this n number in order to get molecular formula. Okay? Simply I am taking one example, C6H12O6. This is the molecular formula of glucose. Okay, this is molecular formula of glucose. Can we calculate empirical formula from this part? Empirical formula should look like this one, CH2O. Okay, now in order to get the molecular formula from empirical formula, we need to know the molecular weight of this compound. Can you calculate? It should come as 12 into 6 plus 12 plus 6 into 16. Just calculate it. Let me just try. 72 plus 96 plus 12. Is that okay? It will come as 9 plus 6. Is that 180? 96 plus 4. Yeah, it will come as 180. So the molecular mass of this compound is 180. The empirical mass will come as 12 plus 16. Empirical mass will come as 30. So you have to calculate the number n. N into 30 is equal to 180. N will come as 6. So you have to multiply this empirical formula by this number 6. So the overall formula will become H2O, we have to multiply it by 6. It will come as C6H12O6. Again, I am repeating what we did. We have taken this compound and we know molecular weight of this compound, that is 180. Again, we have calculated empirical mass of this compound through this formula. This is empirical formula of this compound. Empirical mass we got as 30. The total molecular mass was 180. We got the value of number n is equal to 6. We have multiplied each term present in empirical formula by this number in order to get the mass. In order to get the molecular formula of the compound, we got it as C6H12O6. That's how we can do empirical formula and molecular formula calculation. So the next topic is percentage composition. In percentage composition, what we are doing, first we are calculating how to calculate mass percentage. Basically, this is percentage composition only. So we are provided with one question: calculate mass percentage of nitrogen in 34 gram of ammonia. You must always remember, if nitrogen NH3 is present, if 1 mole NH3 is present, this will contain 1 mole nitrogen atoms. Okay? So we can simply calculate mass of 1 mole of ammonia, and that will be total mass. Or I can say, we can simply calculate total mass of ammonia. We can divide total mass of nitrogen by total mass of ammonia in order to get the percentage composition. So you have to check in 34 grams of ammonia, how many moles of ammonia are there? Number of moles is equal to mass by molecular mass. So it should be 34 divided by 17. There are 2 moles of NH3. There are 2 moles of NH3 in this case. Out of these 2 moles, there will be 2 moles of, in this 2 mole of ammonia, there will be 2 moles of nitrogen. So mass, what is the mass of 2 moles of nitrogen? 2 into 14. That is the mass of 2 moles of nitrogen. That is 28. Divide by what is the total mass? 34. So this is the into 100 in order to convert it into percentage. In order to convert it into percentage, we have multiplied this term by 100, and we divided the total mass of nitrogen divided by total mass of ammonia in order to get percentage mass composition of nitrogen. So it will come as, and after that you can calculate. I'm just writing it like this only. Okay, you can calculate it. So that's how we can calculate mass composition of each and every element present inside a molecule. Thank you. Thank you everyone. We have completed 3 lectures till now. The 4th lecture will be on. From 4th lecture, we are going to discuss the oxidation states and redox part.